Okay, folks, we're gonna kick it off if that's okay. Last sip of beer, settle, find a comfy spot. Folks on the live stream, let me know how the audio is. We think it's okay, but it might not be okay. Let's find out. Okay. Killing the chill beats. What a shame. Okay, so folks, thanks for coming. Let's settle a little bit. We're going to have some opening remarks and some quick demos. Maybe a little chat at the end, and then we'll get back to networking as soon as possible. Amazing turnout. You know, it's people always ask me why we don't do more of these in London. We totally should. But the reality is, the truth is, it's such an interesting space. There's so much interest in it. It's hard to find space. So we're super blessed for our friends at Speechmatics to host us today. So I'm going to chuck it over to Anthony to give us a little bit of, bit of an intro to who you are and what you do.
Thank you, John. Hi there. Thank you all for coming down this evening and helping us christen our brand new offices in London. Woo! So for those of you who don't know much about us, I guess a quick bit about Speechmatics. At the core of what we do is building foundational speech technology, in particular, world-class speech-to-text models. And our roots, they go back to academia at Cambridge University, where our founder, Tony Robinson, actually pioneered the application of neural networks to real-time speech recognition. I've been told that goes as early as the late 80s, early 90s. But yeah, Speechmatics as we know it was commercialized and came into being around 2014 when Tony started commercializing his research. And yeah, so we've been around for a long time compared to some of the peers in the voice AI space. And we've helped shape it. And yeah, getting to kind of brass tacks, right? Like what makes us different as a speech to text provider? Number one, our models are purpose-built for real-time streaming audio. This makes it perfect for voice agents, high accuracy at low latency. Two, inclusivity is at the core of what we do. Understanding every voice is our mission, and that means understanding different accents, dialects, things that tend to get overlooked at. And then three, languages, being very good at non-English languages with limited training data. And then, yeah, four, which we'll go into a little bit more today, is understanding beyond the pure transcript of what has been said to who said it and how it was said. And this is key, really, because voice agents live and die by the quality of their ears. If the input fails, so does your workflow downstream. On the flip side, if you have high fidelity input, you can do amazing things for users. And yeah, Sam will demo this a bit later with our speaker diarization. And yeah, I guess a bit of housekeeping. We've got the washroom by the entrance over there and fire exits here. And yeah, with that, I'll hand it over to John, or John, are we going on?
So I have a bit of an issue trying to present at the moment because my laptop's being used to live stream and I didn't think to bring two. So we're going to get a bit creative later. So if it's okay, can we bounce it to you, Sam? Or, to be honest, if he's around, let's bounce it to you since it's Speechmatics on deck already. Let's keep it rolling. Okay.
Thank you.
Over to the maestro.
Although, John, don't go far. I need you for a moment. My name is Sam Sykes, and I'm the chief tinkerer at Speechmatics. We started getting involved in voice AI about a year ago, and quite early on, I realized that because we know who is speaking, as Anthony just mentioned, something that the term diarization, because we were starting to see this information contribute into a conversation, we've really tried to push that. So whenever we do voice agents and some of these demonstrations like I'm going to show, oh, it's really bad echo, I'm sorry. Knowing who spoke just lifts the conversation more. Most of the voice AI interactions we have is one-to-one. You know, it's a telephone call, or probably will be. I've already had some spam calls, but it will be telephone call one-to-one. But there are instances where actually knowing who spoke really matters because you can focus in on the person that you're supposed to be having a conversation with, or the agent can. For example, if you were talking to your AI or an assistant and you were in a railway station and there was a loud tannoy, that typically will trigger voice activity within an agent and you get into this eternal loop. Also, you often find in presentations like this, I hope it doesn't go wrong, that the agent will interrupt themselves. You know, I'm sure we've all seen that. So I'm going to do a quick demo. Forgive my childish language, but we are going to come on.
Hello there. Fancy a cheeky game of bullshit bingo? If you're up for it, just tell me your name and where you work. I'll get you set up. Who's in?
I would love to play. My name is Sam, and I am from Speechmatics.
Brilliant. Sam from Speechmatics is in. Who else would like to join Sam in this glorious pursuit of workplace waffle? Just pop your name and where you work. A proper bingo needs more than one.
I didn't know I was doing this somewhat unwillingly. I'm John from Daily, and I'm in as well. Okay.
Smashing. John from Daily is joining the fray, even if he's been ever so slightly voluntold. Right, the bingo board is ready. Words are top secret. Just start chatting. Let's see who's got the best buzzword banter.
So Sam, what was that? Was that your bedtime playlist?
And funny enough, I think it's probably my daughter playing Spotify, and it seems to have accidentally. She's going to get properly told off. Anyway, what the idea here, I don't know if you listened, is we've got to say different words, and there's a score. The white ones are the cheapest. The blue ones, you know, they're quite difficult to get into a good sentence. And then the really random ones are the green, and then see first to get 10, okay? You can't just say the word randomly because it will go, well, try it. Just say one of the words randomly.
I mean, let's keep it in context, right? Let's keep the conversation as part of a fluid, smooth pipeline from Bone.
That really was a ridiculous thing. Coat hanger. Were there any coat hangers needed this evening?
So is the idea here, Sam, that like we can both be having fluid, natural, normal conversation, and what it's going to do is diarize that to know who's speaking, who said the word, and I forgot the words, and yeah, it's sampling the audio in real time to figure out who's the bullshitter, right?
Yeah, exactly. So what is actually going on here is I think if I go back and have a look at the output here, nobody's actually going to be able to read it, but all of the words that are coming out from me have been tagged as me, and from you have been tagged as you. So the language model then gets this information as part of the conversation. They're pretty intelligent things. They can work out what it is, but who said what. But what we're also doing is you can say, I just want to listen to you. So my words in the background would not contribute to the conversation that you are having with the agent. I can try and show that a little later. So you can get it to focus specifically on you or a group of people and to exclude other people. And that's where I was saying about you can get the agent to not respond to people that shouldn't be part of that conversation. But what's going on here is it's remarkably simple. Obviously, it's using Pipecat. And we are taking those words that were said, and the language model is being given the list of these words. I need to.
You're sampling those words. Did I get coat hanger?
No, I think I got that one. Look,
Okay.
I got that one.
Oh, what a silly turnip I am, eh?
Actually, that's an interesting point. So what was happening there is we are actually looking at being able to go to, in fact, it's a mode that you can do, going to the language model within a long stream of words that might be being said. So if you're transcribing, it waited quite a long time for us to finish our discussion before that went to the language model. So we're able to split it down into smaller chunks so that things can be happening in the background.
So if you're talking and I'm saying a word in the background that's on the bingo card, what will happen then? So if I'm just in the background saying the word, we try that.
Hold your horses, gents. We have a winner. John, aka the silly turnip.
Hang on, can we have another go? Can you just get another, can we reset and have another go?
Yeah. That's
No. He can do it.
wow.
We're off to the race. And we're already wowing the crowd. The board is reset with some brand new, totally not ridiculous words. Keep chatting and may the best bingo baller win.
I can't remember what I was going to do. I was going to do a demo. So, Humphrey, can you not actually respond to anybody apart from John and myself? So if anybody else talks, disregard them. I think he's taken that as an okay.
Jellyfish love the attention that hedgehog give them.
Jellyfish. Hedgehog. Oh, I've got to talk about jellyfish in context of a hedgehog. Oh. That's absolutely fantastic.
I don't think it really is how bingo works at all. I think it's just us being prattling around.
So Humphrey, I think we should probably tally the score and declare an overall winner. I'm literally cutting into your demo because I want to take the wheel. Yeah. Oh, really? Okay. I don't want to say that. It's absolutely.
It's supposed to play a really annoying tune if you just say some random word like attention.
All right, well, I'll leave you to it then, Sam. That was a really awesome demo. I'll exit stage left. Alignment, inference, accordion.
Thank you. Okay, oh, shush. Let me just run a different demo. Oh. No, I'll run the demo later. I need to change something, I think. Yeah, what do you want to do? I was going to show making it lock onto a particular speaker. Okay.
Hey there, how can I help you today?
Yeah, hi, buddy. Just wondering how you're getting on.
Oh, thanks for asking. I'm great, just ready to chat whenever you are. What's up?
Okay, so what we've got here is it's just a Pipecat basic UI. You can see the assistant speaking, and then we've just decided with this configuration to put an at and a speaker one with the text. And that is enough for the language model to know me speaking. Now, I've specifically told it to only listen to me. And I've actually just muted my microphone. So if I unmute my microphone. So you will start to see that it will be transcribing me. But if John, if you talk,
Jellyfish accordion. I'm still playing bingo. Ooh, oh, it thinks.
Sounds like you're testing things out a bit. Let me know if there's anything you want me to do,
Can
or if you want
tell
me to
what
just
the
sit.
weather is like in London.
How about me? Can you tell me what it's like in London?
Is it sunny in London?
I've just paused it. So we can see here it's flagging. It's flagging everybody's background. So it's a very simple demo. I just wanted to show that you can tell within code and obviously within function tools, you can then get it to update the configuration by saying, just listen to this person or whatever.
And Sam, this is all happening on model, right? Or is it part of the Pipecat configuration that you built with Speechmatics?
So when you configure Speechmatics within Pipecat, you can say whether you want diarization features or not. And if you enable those, then you have a set of lists that you can populate with speakers, or just within function calls, start to manipulate who it focuses on and who it doesn't.
I guess we'll talk a little bit more about diarization after the demos, but Sam, thank you very much. I mean, working with this stuff day in, day out, this is incredibly impressive. So great job with the demos. Thank you.
Thank you. It's always a challenge to do these things, whether you've got all sorts of AV setup, but thank you, Humphrey, for working.
Thanks, Humphrey. I think, Ioannis, are you here? Yes, can we get you on deck? I have to go, I have to present at the end because my laptop's a busy bee right now. So if you're ready to go, that would be awesome. And we'll keep it rolling on. Yeah.
Okay. Okay, thanks a lot. Okay. Right. Okay. So hi everybody. Quite excited to be here. I'm Ioannis Patras, and I have a double affiliation actually. I am a professor at and the head of Center for Multimodal AI in Queen Mary, University of London. And quite recently, I started as a principal scientist at Tavus. And today I'm here in my capacity from Tavus. And I'm quite excited about that. I will say a lot about what we are doing in the company, but quite open also to discuss things that we are doing at the Center for Multimodal AI towards the end of the presentation or during the meeting afterwards. Now I have a quite difficult role now to play because the previous presentation was really lively and it was excellent. But I'm quite excited also to presenting the things that we are doing at Tavus. And why it is very exciting for me, it is because it is bringing together, it is making a realization, things that I have been working in my research capacity for very, very long. So what is it that we are doing at Tavus for those ones that you do not know about it? We're basically building conversation. Oops. This will work. It doesn't. So you can imagine. Yes. So we don't have voice. But anyway, I'm not sure. Okay. So well, the main idea now is that we are building conversational agents. But building conversational agents, imagine them that it is a kind of a ChatGPT that you are giving to ChatGPT. You are giving it a voice, you are giving it a face, you are giving it eyes, and you are giving it ears. So we are having a ChatGPT that is able to listen to you, see you, how you're saying what you're saying, and at the same time react with the voice, so having a conversational agent, but also produce facial expressions, produce head gestures. And why does this matter? Well, it matters a lot because it is not, as it was said before, what has been said is only part of the signal, is only part of what it is communicated. A lot, actually, very large part of what it is conveyed to the person that we are talking to is on the facial expressions, it is on the voice intonation, it is on the head gestures, it is on it is on the prosody, it is on all the it is a multimodal communication is a happens through a multimodal channel. That's okay. That's okay. That's okay. That's fine. I hope that I gave a little bit of vision to what we are trying to do. And not only the communication, giving it ears and giving it an eyes to a conversational agent is not only useful, it's not only beneficial so that they can understand parts of the communication, but also it can understand what is happening in the background. It can communicate also based on visual information that the user may sometimes want to convey. So what are the use cases? Why are they building them? Why are we building these conversational interfaces? So the sky is the limit. We want to be able to create tutors. We want to create therapists. We want to create interviewers. We want to create assistants, digital assistants. Some of them, and several of them, are already implemented. You can see it also. You can create your own personas, as I will explain in a while, using the interfaces that we provide in the Tavus.io, and I invite you to do so. But enhancing both the capability of our systems to perceive, think, and react, we are trying to go steps further and make even more of those personas available. So how can we create, and what is the interface with which you can play, with which you can interact with what we are doing? You can visit now the Tavus, and we are having interfaces by which you can create conversations. So you can create conversations by creating now the different personas. You can create the conversational context. You can give some instructions to the agent, and these things are going to be given as, getting a little bit under the hood, these are going to be given as context into the LLM that currently is the central brain of the whole system, and to a VLM, so visual language model, that understands what is happening in the background and understands things about the user, so that they can create the appropriate responses. So here I'll say a little bit about how things work, and afterwards I will explain a little bit what we are going to do next and what is our challenges that we're trying to address. So the first thing that the Tavus allows you at the moment to do is, first of all, to bring hyper-realistic replicas, which means that you visit the site, you upload 2-minute videos of yourself or whatever person you want to replicate, and it creates a 3D model together with texture that it is able to reproduce, given the appropriate instructions, all your facial expressions, the speech, teeth, amazing actually quality. Then you can create now the personas, as I explained previously, giving the background to it, giving the appropriate context. And then you can create also a conversational API. Now, how this works is that it has 3 layers. It has a perception layer in which you are analyzing the behavior of the user, speech and nonverbal behavior, but also, and I will say a few things about it in a second. Then there is an thinking process in which basically it is an LLM that it is doing the heavy lifting, and it is producing now both the text of the output, but also controls to the text-to-speech model and to a rendering model, so that it can generate the facial expressions, that it can animate the avatar, but also that it will animate the avatar using the speech signal, but also using some other signals that control some things like control emotions, for example. So now, how do I come into the picture? I came late into the picture, so very recently. I just started 1 month ago, but I have a very long experience in the academia and in a company. I was a chief scientist in Huawei research in Finland, where my main expertise could be characterized by by the sentence at the top, which is looking at and sensing people. And the main thing is that we are using computer vision, machine learning methodologies, so as to sense what people are doing, understand their behavior, understand their facial expressions, understand their mental state, understand the cognitive state. I have worked also a lot on multimodal machine learning, treating low-level problems like doing a self-supervision model, but also working on alignment of LLMs and control of LLMs, which is quite important if you want to create personas and if you want to create safe and controllable conversational interfaces. Uncertainty quantification, which is also quite important because it is you're saying things, but how certain you are that the answers are what the user would want. And finally, what I have both at Queen Mary, but also a part of the work that I have been doing in Huawei, is generation. So generation of video and generation of images using primarily primarily diffusion models. So how all these things are important? Well, they are important for all the levels that are important for making conversational agents a reality. And conversational agents that are natural. So this is the key word here, that they are natural, that they are as close as possible to human conversation as possible, as I say. And I put in the parentheses more because already the work that we are doing in Tavus and the system that it is there is going a long way in providing natural interactions. So, as I said, I just started. This I'm only a month there, but there is a lot of work that we want to do in the perception side, so to understand user behavior, and we are working, or will be working more on enhancing the capabilities that we have to sense the emotions of the user, sense the emotion of the person that we are talking to, social signal, understand non-speech vocalization, all of these things that are important in the conversation. And of course, we want to have low latency in doing the things real time. There is work that we have to do on thinking. Currently, the heavy lifting is being done by an LLM that it is giving instructions with some kind of prompting, and but this is something that we will need to change and we will need to enhance if we want to go to the next level. And of course, we have to work on the response generation. We have already, I believe, really state-of-the-art renderer for generating and controlling the avatar. There is a lot of expertise here about the text-to-speech models and the controls that are being given to it. What we want to do is to have a way of giving to the signal, giving to the TTS, to giving the appropriate controls based on the flow of the conversation. And this is something that it is not trivial to do, and it will require a lot of conversational data that it is going to be is to be used, and a lot of multimodal data, because what we want to do is that we want to have this sense, speech, face, generate speech, generate face. This is roughly what I wanted to say, and say also that we are hiring at the moment. We are expanding. It is rapidly developing the company, and I'm very excited to be there. We are hiring both in research positions, both in perception, both in rendering and in voice, and having also engineering positions for data and for software engineering. Data is a very, very, very important issue, and we are looking forward to get it right. Thank you very much. Darle yo.
Thank you so much. I think is Ian here? Oh, just on time. Are you ready to go? Awesome. Sound-wise, how are we going to do this, Sam? Okay, I'll tell you what, we're going to take 2 minutes, do some AV stuff, just for the benefit of the folks on the live stream. Hello, folks. And then we'll be back. Sorry for the bad flow. We'll keep it.
Did Gemini?
Is the boss line?
Hello, hello. Hello, hello, 1 2 1 2. Hello. Hello, hello. 1 2 1 2. Hello, hello. Hello, hello. Can everybody hear me? Hello, hello, 1 2 1 2. Hello. obviously, I was thinking of some interesting things to show. And one thing I thought that would be really suitable to show is we have a demo that we've been doing at a number of different events called the Interactive Vehicle Manual. And this is like a good example of our live streaming API that we have. So first question, has anybody used Gemini Live? Quick show of hands. Okay. Probably about like a third of people. Has anybody developed anything using the live API? One or two. Ooh, fantastic. Then you are the right people for me to talk to. So, so if you didn't know, Google obviously has a number of AI models, the Gemini series, and they have a live API, which is a bidirectional streaming API. So with it, you can send audio and video, and you can talk to the model and you get responses back. So like, compared to like, traditional systems that have a speech to text and then an LLM and then a text to speech model, we actually have a cascaded architecture. So the model natively understands the audio, and you have the option of having a TTS output, which you can control, or we do a full kind of audio to audio mode. So I'm going to see if I can show you a couple of different examples of this. And what's really cool about this technology is that you can use it to, say, for instance, show like images of things around the room with your phone, or you can share your screen and you can talk to the model about your screen. So basically just having a live interaction with it. And one of the things I want to talk about a little bit is some of the challenges that come with talking to like an audio to audio model. Some of the things that it's very powerful for, like its understanding of like nuance and tone and other stuff like that. And some of the things that's kind of harder to get it to do, like, reliably take actions and basically do the specific tasks that you need to do. So I'm hoping to show you that to use these kind of tools, you need to kind of switch your mindset from like, traditional kind of structured, tested like workflows to a more kind of exploratory mechanism to understand what the models are capable of and how to get them to reliably do the same actions. So I'm going to show you a couple of slides from here, which is our vehicle demo. So actually, do you know what? We're going to go straight. I'm going to show you the video. Who better to explain what's happening than past me? So have a look. So you can type messages to Gemini, but not only that, you can actually talk to Gemini as well. What I'm going to do here is I'm going to open the microphone so you can talk to Gemini, and then Gemini's going to explain to me how to drive this car. Let's go.
Hello there, welcome to the driver's seat of the amazing quantum Jet 3 genomic magnitude. I'll be your instructor today.
The model understands a lot about the game, the controls of the game, and a little bit about Formula E. We can give you some history about it. How do I drive the car?
Let's get in.
I have a gamepad, so what are the controls for the gamepad?
Of course, the right trigger will be your phone, and the left trigger is your brain.
And the way we kind of built it is using like a framework. So you can take an application like this or a game, and then you can pass in the audio and the video input, and then give it to Gemini, streaming through the live API, and it's able to respond to you and talk to you and give you output. Where am I, by the way?
I'm exactly racing at
And the model itself is also able to do things like function calls. So it can help by like toggling driver assist. Can you tell me how fast I'm driving?
According to this phenomenon, you're currently traveling at 2.5 kilometers per hour. Not pursuing.
No, that's super useful, thank you. And we built this on top of an application called the Live API Web Console, which is basically it's like a framework boilerplate for building applications. So if you're interested, you can go to AI Studio, you can try the Live API, you can talk to Gemini. And if you want to build something, you can use the Live API Web Console and download that, build that, run that in your application yourself. So there you go. So I hope that painted a little bit of a picture about what it does. We took this particular demo to obviously Google I/O and then a number of different I/O Connect events, Cloud Summit events in London and other places around the world. And one of the cool bits is we got to basically use it with like a full driving simulator rig. So you imagine the users would come and they'd sit in the vehicle and they'd sit down and they'd say, "What do I do?" And the model is designed to understand a lot about the vehicle itself, understand how to actually control the game, and is able to kind of give you like what we described as an interactive manual, like instructions. So instead of you reading like 20 pages of how do I operate this, you just ask the questions that are on your mind, like what are the controls? Like what button do I need to press to turn on the boost? Like how do I configure things within the menu? So in order to do that, this is the architecture that we used. Loading. Yeah, so using a live API, we're streaming the audio and video, basically, of the game. And that goes in through the capture module, then sends it off to the model directly. So there's nothing in between those steps. Like, you're sending the raw data straight to Gemini, and Gemini is processing it. Then what it does is it will respond with an audio stream and also with actions that it can take. So we've actually, in this example, we've programmed it to understand that it can toggle the driving assist of the car. So if someone's particularly struggling or that they're spinning out a lot, you can say, like, turn on traction control, and the model will take that action for you. So that's combined basically with like a task management system, and we have these game profiles. And all the game profile does is just tell the model what actions it can take within the game. And I'll let you in a really dirty secret. All it does is just press a button on the keyboard to actually trigger the action in the game. So what's cool about this is that we haven't built the integration straight into the game. We've built it as like a wrapper around it that you could just apply to any application. And obviously you have like this little UI debug console, so you can see what's going on, and I'll show you how that bit works as well. And you can just do this today. If you go to the GitHub project and you download this app here, all you would need is like a set of system instructions to explain to the model about the game, and then you'll be good to go. There's nothing custom, nothing bespoke, which is the main takeaway from this at the end. So you could definitely try it. So should we try and do a live demo? Yeah, that's what you're all here for, right? So usual caveats, if it goes wrong, we applaud because. Right, so I'm going to cheat a little bit. As you may have noticed, I don't have a gamepad or a driving rig. So what I'm going to do is I'm going to play a video, and I'm going to have the model look at the video, and I'm just going to ask it questions about the video. But imagine I'm kind of like sitting in the driver's seat. So let's start it up. There we go. Let's pick the right version. There we go. Load the model. And I should have somewhere here. There we go. There's my game. Let's just start from the start. And then I will go into here. I've got to share my screen. Once I share my screen, then Gemini is able to actually see this. And then hopefully I can jump back. And we will see whether... Hey there.
Hello there. Welcome to the driver's seat of the amazing Formula E Gen 3 and R Factor 2. My name is Alex, and I will be your instructor today. I'm here to help you get familiar with this fantastic car. No question is too silly, so please ask away. To start, are you wondering what Formula E is? Or do you want to know how to drive the car? I see that you are in neutral. The dashboard indicates N. To start driving, you need to shift into first gear. With your current gamepad configuration, you can do this by pressing the right trigger.
I don't have a gamepad, but let's not worry about that now. So how do I go into the next gear, you said?
All right. To shift up to the next gear, you need to press the upshift button, which is defaulted to the left Alt key on the keyboard. Give that a try.
Okay, what if I was using a steering wheel?
Great. Since you are using a steering wheel, have you mapped the upshift control to one of the paddle shifters on the wheel?
I have
Use for upshift.
I have done that.
Okay, I see you're still in neutral, but the car may not have shifted into gear.
Okay, so how do I go forwards?
The way to go forward in the Formula E Gen 3 car is to apply the throttle, which is by pressing the rightmost pedal in your standard sim racing pedals.
Okay, I'm doing that now. I think it's working.
Great, you are up and running. What next? Do you want to go faster? Or are you happy just cruising for the moment?
Yeah, just can you give me some background about Formula E? Tell me a little bit about the sport, because I have no idea.
Certainly, Formula E is an all-electric international single-seater championship. It's a bit different from other motorsports because it focuses on energy management. The Gen 3 cars you're driving are capable of speeds up to 200 miles per hour.
Okay, you're right. I want to go faster. How do I go faster?
The first thing to check is the speed limiter. Make sure that is not enabled by pressing the red button on the left side of the steering wheel.
Okay, let's do that. Okay, yes, I guess I'm now going faster.
hitting that speed. Now that you're rolling, are you interested in learning about tech mode, which gives you an extra burst of power?
Sure, tell me about that.
Great. Attack mode is a unique feature in Formula E. It provides a temporary power boost, adding an extra 50 kilowatts to your car's output for a limited time. Activating attack mode involves a two-step process.
Okay, hold on. Before we get to that, I'm struggling to brake. Is there any reason why it'd be hard to brake?
Sure. One common reason is that the Formula E Gen 3 car uses a regenerative braking system, which might feel different than what you're used to. The brake pedal primarily controls the amount of energy regeneration blended with front friction brakes. Are you pressing the brake pedal firmly enough?
I am now because I've stopped. Oh, can you read what's at the side of the track?
All right. Looking at the side of the track, I see the words Google Cloud displayed. Is there anything else you'd like me to identify?
Yeah, I've got one tricky one for you. Can you tell me how fast my last lap was?
I sure can. I'm looking at the bottom right of the screen, and your last lap time was 1 minute 45.453 seconds.
Wait, okay, we got there. So there you go. So
Fantastic. Is there anything else I can help you with today? Perhaps you want to go over energy management techniques.
I would love to add another time. Yeah, so there you go. So thank you. So you can see we combine like a different kind of natural conversation, asking questions to kind of also interrupting the model. I think by now, a lot of folks who've been using AI voice models for a while understand that humans aren't quite ready for this from like a interaction perspective. And what we want to try and do is make conversation more natural, make voices more natural, and get it to the point where it's almost kind of seamless. So one thing we find when people use this a lot is that they don't interrupt the model. They just kind of let it talk and it will just kind of waffle on for hours and hours and hours. So you want to be able to give people control so they know how they can interact with it. One way you can do that is you can control a lot of this behavior through system instructions. So the language models themselves, they're very, very good at following instructions. So all the information that it told me there about like what's in the vehicle and how to do the different controls, what the buttons do, is in basically a 20-page manual that we fed to it. And it's very good at pinpointing specific things out of that data. So when I said I'm using a steering wheel rather than a gamepad, it adapts its knowledge and looks at a different section of the manual. And one thing we were finding in the demo was that people were driving really slowly because they had the pit limiter on. So we added a section to the system instructions specifically saying causes of slow speed might be you're not accelerating hard enough, or you're in the wrong gear, or you might have the pit limiter on. So by putting that information within this prompt, the model is able to reliably pick it out because we've kind of given it like a common set of causes. So you can have like kind of very structured workflows, but one of the big challenges that we found is very difficult to kind of evaluate this because the best way to do it really is to just talk to it. You can have pre-recorded audio, but obviously the path that the model takes is going to be different every time. So that's one of the challenges to look out for. I'm going to show you one last little demo, and then if there's have you done a quick Q&A? Is that
Already out of time.
okay? Right.
You can show your demo. I would love to show folks my silly spaceship thing off the back of that.
Yeah.
And if you've got time, folks want to stick around, you can show. If that's okay, I don't want to interrupt you when you're.
Yeah. No worries. No worries.
Definitely want to wrap it up soon. And
Maybe one last ask one question that is relevant for everybody. Most people here are using a TTS pipeline. Should we be using real-time native audio? What way is it going for any of you members of time?
Gotcha.
What step should we build?
Yeah.
This isn't. We're going to get such different answers.
Yeah.
From Pipecat, right, and from Gemini. I think we should come back to that if that's okay. Demos, dive into Q&A and networking if that's all right, folks. It's a brilliant question. I've got lots to say on it. But if you don't mind, it's just and for the folks on the live stream, I'm sorry we have to say goodbye because I need to use my laptop. So I will share a recording afterwards of everything we show from here on out. But thank you for tuning in. It's weird, they're not even here. I'm talking to them. Thank you so much.